Okay, let's take a look at some more graphical representations. We've talked about some already in the previous lessons. Now here's a list of different representations. We're not going to show you pictures. You can look in our textbook to see some examples of these. And you can, of course, Google and search them. Most importantly, I think, out of these is that depending upon the type of variable that we have data for, helps determine which graphs we want to use and essentially how we want to view that data. And so you can see a list of things here. We've talked about some of these, like I said, in previous lessons here, and we'll utilize some of these even more. And some of you've seen before. So this first example, just to demonstrate a dot plot, because that's one of the most common graphical representations that we use to look at a distribution, and it's similar to a histogram. Important to acknowledge here is that the dots represent a single data point or a value, and so you can actually count how many or what the frequency is, right, along with the distribution, where a histogram many times has a continuous interval, right, in a bar that represents values between some given values. Many times dot plots are for discrete values, as you see here. And so we took these numbers and then we put them on a line, and that's another name for a dot plot, but I think dot plot's probably the more common term you'll hear. And so you can see each dot is above that value. And that's a distribution here. And this, again, just some made up data of high temperatures in a city in California in July. What I really want to discuss, and something that you probably will do in class or with others, but we can quickly review, you can look at these answers here, is looking at these distributions, these dot plots. These are hypothetical exam scores from classes. And so you can see the questions here about what are the shapes of these, right? I see symmetry mostly, a couple of outliers potentially here, as you see here, but again, we're just kind of generally describing these things, and then also what are the characteristics that distinguish these things. And for me, you will see that they have different centers, right? Their middles are slightly, their middles here, as you look carefully here, you'll see kind of the middle points, right? They have different centers, right? And that goes back to measures of center, which we're going to talk about in the next lesson, kind of like the means. Where's the middle value? And what would that mean? I think for the class, that they maybe perform differently, right? This had the highest average, that there was a difference in performance. We have a couple other graphs to analyze here. Here's another distinct looking distribution. This is skewed to the left. There are a lot of people scored over here, and maybe since no one's higher than 80, that was the highest test score. Again, this is a hypothetical test. Maybe the exam was easy, that's why so many. But again, there's a story to be told with every distribution, right? And it's up to us to kind of look at the context and think about what would explain what we see, right? What do we notice, and what are we wondering about? And then what evidence do we have with respect to how this would be, right? We only have some guesses here without being in the class, right? That maybe it's easy. Maybe everyone cheated. Maybe, again, we can come up with something else, right? Moving on to B and C, looking at these distributions here, I see two separate distributions, which made me think that there may be two different types of students in the class, or this data came from two different classes. One class that was maybe underperforming, and one is overperforming. But again, you can see there's two separate kind of modes. It's bimodal, right? Which is an indication that maybe that there's something up with the population, right? There's two different groups here. And we again have a couple of outliers and some really below down here. And then on C here, we're looking at this here. I see some outliers way over here. Kind of symmetric, but not what we're going to call normal, right? Not necessarily normal, but it looks like definitely symmetric with high mode here. I don't know what the high score was, but maybe it was 80 also. But most students scored between 65 and 75 if you look carefully, right? It was really kind of bunched up together, which we'll talk about those characteristics as we go on. And lastly here, a challenge here. This is just one distribution that could exist with these scenarios here. Most students score in between here with a range from 30 to 100. right? And so again, no A's, not many people fail, but everyone kind of in between that that high D and low B range right here. That's the distribution. That will be a sample dot plot.